Good morning, everyone. Today, I want to present the research did by my students and I, which is on UAV-based attack-free structure monitoring damage identification. And this research is supported by ND EPSCoR seed grant. And in here, we'll talk about the introduction to objectives of this research. Then we discuss the material and method, and I will then present the results to you. Finally, we will draw some conclusions and give you the references for this research. Now, the first page, I want to show you the PDF of the post. I will then switch to the presentation that goes with it. Okay, so the the presentation is on UAV-based attack-free structure monitoring and damage identification. And we know that computer vision is widely adopted in literature to perform structure enhanced monitoring. The core of computer vision technology is on image processing, right? And its accuracy heavily depends on the quality of the input images. And if the image captured by the camera was distorted, either due to the vibration of the camera itself or due to the environmental effects such as wind, and it will reduce the displacement monitored in practice. And we know besides the version sensors, there are many other kinetic and non-kinetic sensors, right? They are either directly deployment on the surface, and also they have another drawback, which is they're low in accuracy. So those kinetic displacement sensors, including the LVDT, accelerometers, inclinometers, and those and strain gauges too. Those are the sensors was put on the surface of the structure. The second category, which is we call non-kinetic displacement sensors. Those, for example, include laser, radar, and GPS, and also the old traditional vision sensors too. As we just discussed, those sensors first it's not very convenient, and it's need to be deployed, on the surface, even for some non-kinetic sensors, but the accuracy for those sensors are pretty low. For monitoring of a structure, it typically requires less than 1 millimeter accuracy, right? So most of the GPS sensors cannot achieve that level of accuracy. So in this research, we want to develop a fast vision-based attack-free displacement sensors for structures. We want to create a method to field 3 translations and 3 rotations of UAVs, and also we want to perform condition assessment and damage identification for lab and field structures. So the research method we present here, including the tag-free edge coordinate funding method, and also we want to improve the accuracy through subpixel precision in edge coordinate funding through zenith moment method, and also we present a recursive method to field 6 motion of the UAVs, and also we discuss a skip normal template matching method that can increase the accuracy and speed of image processing. So the research method for free target method, which is we show you here, right? If we have a image, we first convert it to grayscale, then we use edge detection to find the edges, right? Then we calculate the coordinates, use the subpixel zenith matrix method. Then we trace one of the points and determine the displacement of the structures. And also we can sometimes due to the vibration of the camera, and we need to filter those vibrations. So here we proposed a recursive template matching method which is we search all the images with a template in the background that's either due to a mountain or a fixed, background in the picture. And also we can increase those template match methods through a skipped NCC method, which is basically we can check the image block with a certain distance, then we find the maximum one that we zoom in to look into the local region to find kind of a reference point for calculation of the displacement. And if its rotation happened, we can retreat it back to the original state too. So with those, we can get the displacement monitor accurately. And here we show you several examples. The first picture showing here, if we use subpixel method, it's increased the accuracy quite a bit. And this is a method we did through UAV with a shake input. We see if without those corrections, the displacement that we find is quite away from the true input. But with the method we suggest here, it captures the vibration very accurately. So with that, I draw a conclusion, right? So the method we proposed here is a target-free, efficient method to trace displacement. And also this method can filter all the 6 motions of the camera. And, the proposed skipped NCC-based template matching method can improve and enhance the speed of the image processing. And, if with that, which is we tested and validated through the lab and field testing, the method is quite accurate. If without such, a method, the displacement, captured use the conventional or the image process method, the error could be very big. Okay, with that, I will conclude my presentation and welcome your questions. Thank you. Bye-bye.